Good morning. I'd just like to take you through a tutorial on how to produce an engineering drawing for a computer storage unit. Now, if we look here, you can see there's the product. Okay, and looking at the journey, I'm going to take you through a whole sort of tutorial how to build. This was a storage unit for a computer console, PlayStation 4, games and peripheral devices. Okay, so the first thing we do, if I just edit sketch, you can see that the table was 800mm by 450. So all it would do is go up here and sketch a 2-point rectangle, 450 by 800. That would be your base, right? Good. If I just go into an isometric view, stop sketch, you could then see that the next stage then would be to extrude that to a height of 600mm. So if you go back to that original 800 by 450, I've extruded that to 600, so you end up with a solid rectangle. Okay. Now, many students struggle with this, but if you make it to scale, exactly 1-to-1 scale, then it's very simple to turn that into a DXF file. You can save it and CNC machine it on a router. Okay, good. So if I just click on stop sketch again, good. The next stage, what I would do then, I'd look at the side profile and I would draw two rectangles, again 2-point rectangles with an 18mm thickness. And in fact, in this case, it wasn't 18, it was 10mm 10mm oak-faced MDF is what we used. Okay. Oh, sorry, 9mm, not 10mm. You would then cut out these two sections. Again, if I click on stop sketch, you can see on the next bit there, all we would do, we'd cut that through both sides. So you'd end up with a shell. Okay, so that would be upper shelf, and that would be the lower. And it's quite a nice way of teaching your students how to produce a GCSE project. Okay, so the next sketch that we're doing, if I look at the next one here, edit sketch, you can see now that I'm going to cut out that whole section because that was going to be the roof part of the product. Okay, so if I click stop sketch again, you can see what happens with that. Edit sketch, and that would be cut back 400, leaving a space at the back, because on top of here there's going to be a rolling. We're going to use two interlocking hinges that slide out. Okay, on a roller system, and with a push fit. Okay. Very useful indeed. So the drawer would slide out over this part, over this compartment. Okay, so I'm happy with that. Right. Next. So the next stage, we'd look at this part. I would just double check that you've cut out the bottom and the top. Again, we're removing that material, and this is where you're going to store the PlayStation. It could either be top level or bottom, it doesn't really matter, but the student has considered all the dimensions for the PlayStation console and the games, and they fit into the upper or lower part of the product. Good. So I'll stop sketch again, and the next stage. Okay, what I've done here, you can see we've mapped out that section. And again, edit feature. This part would need to be extruded to 3mm, because 3mm was the thickness of the acrylic. Okay, the acrylic top that slides over was 3mm. Okay, so that's a good start. After that, edit sketch. We then draw the two sort of L-shaped pieces, and what I always tend to do is put a centre line in. I've deleted it on here, but a centre line in the middle, and then you choose a mirror, so you would mirror that pattern about the centre line to get a replica on the other side. Okay, so you'd select the object and mirror at that point there. Okay, this is just a run through, just so you can visually see what and how we did this. Okay, because you think about it, in the GCSE, the students are only required 2 hours to produce the engineering drawing. Okay, so I'm going to click on that. So then, edit feature, that would then be extruded to a distance of 450, which then coincides with the length from here to here, and that would roll out on this lovely draw system. You'll see the finished item. If I just click on here, if I go down to the bottom here, just come out of that, that's fine. Yeah, there's a part of drawing, so that was going to be the sliding lid. Alright, anyway, that's that. Okay, you can see from the development of the final idea, looking back to the CAD that I'm looking at the moment, you can see the students looked at developing draw systems, a sliding top here, a bit of modelling out of foam board, very useful. But if you look here, you can see that the students been able to produce a cutting list. We keep it basic, okay, so the tabletop is 3mm acrylic, finish would require a polish. The table side dimensions are there. It was 18mm oak-faced MDF. The shelf and the feet, okay, rubber feet that were textured, and aluminium inserts. They were inserted on the shelf here to hold that up. But you can see visually, from a student point of view and an examiner's point of view, you've got a cutting list, a 3D sort of shape, an isometric view, a rendered view, an engineering drawing with a front view, plan view, side view. We also, from that, we can then produce a drawing with the processes, techniques, and the final engineering drawing is here. Okay, so this is why we find the Fusion 360 very useful. If you've got a good product, a good finished product, you can then produce a detailed production plan with the part name, the time, the task number, the task, the tools and equipment, quality assurance, health and safety control measures, comments, justifications. Okay, you know, this may not be the one of the better projects, but at least middle of the road. It's a good logical sequence of production plan, and it's very useful. Which then leads on to the making diary. So we've got biscuit joints, frame construction, iron on edging, the rest speaks for itself. Use of hand tools. Moving on, these are the inserts, bit of laser cutting, strip heater. These were the draw runners, again with the push fit, 3mm frame. It's slightly different to the engineering drawing, but that's what happens during production. They do change, and students realise there are alternative ways of making it. And then down here you can see some of the stages, some of the testing that was done, and the painting during manufacture. This is the finished item, okay, with TV on top, game controllers, everything fits in quite nicely. Testing, what we tend to do is do a drop test, capacity test, functional test, make sure that the draw runners slide out nicely without any kind of defect on the lid. We also get the students to do a liquid resistance test to make sure that the work is completely waterproof and functional. A weight test, and that is basically what we do. And then a client summary as per GCSE specification. So really, it was kind of a side table with a difference. Okay, good. Let's go back to Fusion. Great. So there we go. There's the 450. We click OK on that. Again, that was extruded. Then what you do, then you would just edit feature. You come along and add your radiuses on these edges. So I put a 10mm one there, 10mm edge on there. Job done. That's it. And then finally, before I finish off, what you can do as well, click on model, go to render, and again, quick and easy, what I tend to do is do a quick render. Alright, down here you've got these different views. Okay, so you've got like a front view, isometric view, a side view, and a plan view of the product. That's quite handy. But if I go up here, and you can see you've got physical materials. If I wanted to change the appearance, I could change that if I wanted to. But what I tend to do is do an in-canvas render, like so. So I click on that. There we go. And what it does an in-canvas render quickly. And it doesn't take long. I mean, that's 6-7 seconds rendering. The students can then print screen, bring that into the folder, and use it for their development. Okay, good. And if I was to press print screen, I could print screen it, come back into here, go back up here. There you go. If I want to do it as part of a development, I'll just dump it in here for now, just for the sake of it. Paste it in there. In comes the screenshot. You would crop the image accordingly. Okay. Now, just grab hold of that. Make it slightly smaller. And the same here. And what I like about it is that could then be inserted into Google Slides. We use Google Slides, very quick and easy. You know, and there's a screenshot. You know, if you look at that in comparison to the model here, it's very similar. All right, it works. It's really good, really good. All right, good. I'll just nip back into Fusion, and if I wanted to get a different view, I can rotate the model. Now I'll have a look from behind. There you go, and I can zoom in again. I want more detail. Now structurally, you can see the makeup of the product. Yeah, in final manufacture, it did change slightly, but that's normal. That's normal. But the physical CAD drawing was a resemblance of what the student intended on making. Okay, so I could do the same again. I can print screen it, bring it back into my Google Drive, and I may want to use that, say here. If I go into slide 18, dump it in here, paste. Alright, I could use that then accordingly. Okay, so I'd crop that image, reduce it, focus on the part I'm looking at. So I'm looking at the biscuit joint on the top there. That's all I'd be interested in. And if you look here on the modelling, the physical models that were made out of mahogany, you can see that the CAD drawing does fit in with the physical model that was made by the student. Okay, all right. Now he didn't use this in his final GCSE folder because this was the final idea, but it works. Anyway, let's go back to Fusion. I hope you've enjoyed my quick introduction into modelling using Fusion 360 with a GCSE project. Thank you very much.